Red-green colorblindness. Colorblindness is a defect of vision affecting the ability to distinguish colors. Light passes through your cornea and lens and hits the retina. Long wavelengths of light excite cone cells in your retina, of which there are 3. L cones for long wavelengths, S cones for short wavelength, and M cones for medium wavelengths. Your brain then determines which cone is excited the most to determine which color you're seeing. There are 4 types of red-green color defects. There's deuteranopia, which people lack the medium wavelength green cone, meaning they cannot see green at all. There's protanopia, which is people lacking the L cone that can see the wavelength of L, so they can't see the wavelength of L at all. And then there's deuteranomaly, which is in this, the cones that respond to green color wavelengths are shifted a bit, but they can still see some hues. A person with this is considered green weak. In protanomaly, the wavelengths the red cones can see are shifted, so the colors can blend together a bit, and these are the L cones. A person with this is considered red weak. The causes for red-green colorblindness can be damage to the retina from physical trauma or to the path from the retina to the visual cortex. Diseases like degenerative eye disease, like macular degeneration, glaucoma, or other diseases like diabetes, Alzheimer's, or liver disease. The OPN1LW is the gene that's responsible for creating the protein, which is called opsin, in the cone cells that react to the long wavelengths of light in the cone cell. This happens during meiosis when the sister chromatids are crossing over. They cross over unequally, which is called unequal recombination. Similarly, the OPN1MW is the gene responsible for creating the protein called opsin in the cone cells that react to the medium wavelength of light, which is green. Again, this happens during meiosis with unequal crossing over between the sister chromatids. The gene location is XQ28 for both. The pattern of inheritance, it is an X-linked recessive, which is on the X chromosome. Because men only have one X chromosome, in order for a man to have color blindness, they need one X chromosome that has the recessive trait for color blindness from one parent. And this is why they get it more often. Women, however, to be colorblind, need a gene from both of their parents.
Among populations with Northern European ancestry, it occurs in about 1 in 12 males and 1 in 200 females. Red color vision defects have a lower incidence in other demographics. 5.6% of Caucasian boys, 3.1% of Asian boys, 2.6% for Hispanic boys, and then 1.4% of African American boys. So the Ishihara test plates, color vision deficiency is usually detected using these charts. The plates consist of gray and colored dots. The patient is asked to identify the number in the middle of the circle, and after they have identified it, more testing may commence. And then this test, the Richmond HRR is similar to the Ishihara. However, it includes symbols, which can be more helpful across cultural lines since the Ishihara uses the Arabic numeral system and children who have not learned their numbers yet. So in using an anemalscope, the patient looks into the eyepiece to see a mixture of red and green, which is presented in the top half of the display. The bottom half of the test field is yellow. The patient adjusts the field to match the color of the test field. Inherited colorblindness is not treatable. However, there are methods of dealing with the disease and making things easier. A company makes special glasses which can help those whose cone cells have just shifted, not those who lack the cells. And then colorblind friendly design in media and entertainment, such as these colors for the game Imposter.
We hope you learned a lot from our presentation, and thank you.